let's just start with the stats and data. Do you remember we had a test where you'd be asked questions about these guys? And let's say this was 2, 4, 5.5, 7, and 10. You should know what all of those are. I think you do. So I'm not going to spend too much time on this. But if I asked for the IQR, a lot of people don't know that one. If you know it, write it down. Take a second right now and write down the answer. What is the IQR? And if you don't know it, I'll tell you in a second. Everything I am doing is preparing you for that final. So I'm not wasting your time here. You want to practice all of these. How many of you knew that that involved range? Raise your hand if you knew that that was about range. You didn't know that? Interquartile range, that's what IQR stands for. Max, are you still with me? Okay, good. Just do this. This is important. The IQR in this case would be 3. Gabe, can you tell me why it's 3? Yep. And 7 minus 4 is 3. Okay. This one, this 5.5, it's either the mean or it's the median. Which one is it? It isn't both. Which one is it on a box plot? Is it the mean or is it the median? Yes. What do you think? I thought you were raising your hand, but just give it your best guess. I don't care. All right. And does anybody else think it's the median?
Yep.
You have to choose a side now. All right, so you're either on the mean or the median side. Raise your hand if you're going for mean. Raise your hand if you're going for median. More people are picking median. That's the only two. It is the median. It's the middle one. And the median means middle one. Okay, another one that I couldn't believe how many people got this one wrong. Mode. Do you know which one the mode is? It's the one that happened the most. Is it one of these 5?
No.
Probably not. No. It's whatever number happened the most. Okay. And then just range. And tons of kids write 2 to 10. Mr. Nichols, what do I write for range?
10 minus 2 is
10 minus 2, which is 8. Yes. Okay, good. All right. Now, last question about these. We could have 5 finals questions about just this chart. Here's another one. What is the percent of data, the percent of the numbers that are between 2 and 7? Remember that these are little sets of 25%, 25%, 25%, 25%. If you say anything other than 25, 50, 75, or 100, you're not answering this right. So if it's between 2 and 7, can you tell that that is 75%? Because it's 3 sets of 25. 25 for this, 25 for this, 25 for this. So that's 75% of the data is between 2 and 7. All right. Now there's another main kind that looks like this, and this is the normal curve. You do not have to draw this. I would find the kids would take too long just drawing it. I just want you to answer a question about it. Let's say that this is, you weighed a whole bunch of snakes. I knew a person who had snakes under their house. It was terrifying for them. They were seeing snakes around their yard all the time. Snakes that would crawl in between the siding of their house. They'd see a snake head sticking out. So let's say, and this is actually true, they use sticky traps to catch the snakes. So now they realize where the snakes kind of tend to slither out from, and they'd put sticky traps down, and then the snakes would get stuck in there. And so let's say that they weighed the snakes, which wouldn't be that hard. You weigh your sticky trap beforehand, and then you put the sticky trap with the snake on the scale, and you could weigh the snake, and they got an average of 400 grams. Don't write this all down. I'm just going to ask you a question about it. And on the worksheet, it says that weird symbol, X, is 20. Do you know what that weird symbol is? You're supposed to know that one. 2 words. Say it if you know it.
sigma.
And the sigma is the symbol, but what's that called? Standard deviation. Okay. Now that is how much they deviate. All right. What if at another person's house, the standard deviation of the snakes that they caught was only 2? All right. tons of people got this question wrong on the test. Pay attention. These snakes were more spread out. Some of them were really big, some of them were really small. These snakes were all really close in size to each other. They were very close together. So it's about how spread out the data is. And this is spread out. And the data here is close together. All right, so let's go with the 20 for our problem. This was just a comparison one. We typically do that. If I put 2 bars here, you should know what those are. All right, now I know some of you are having a low motivation, I can tell it. I know some of you are locked in and you're good. But I want to give you this like reminder. This is it, boys and girls. This is the last lesson of the year. Tomorrow is just a practice test. It's a practice final. Okay, this is it. And it's only going to be about 15 more minutes. And most of you are going to do worse on your final than you do on an average test because it covers so many things. And so you're all in risk that your grade, whatever it is right now, if you do worse on the final, there's a chance you could lose the grade you have right now. Say you've got a B+ and you really like it. You don't want it to drop. Well, this is your moment. The next 15 minutes might be enough, if you really focus, to keep you from losing your semester grade and dropping from a B+ to a regular B. Okay? Nobody's going to go down, well, yes, it's possible. It'd be really hard to go down 2 half grades from like an A- to a B. That's 2 half steps. That'd be really hard. But a lot of you could drop a half step. Your A- all of a sudden is gone and you got a B+ now. All because of one test. So focus. Do your best here. All right, so this number right here should have been add 20 and you got 420. This one, you subtract 20 and you got 380. Do you know how to do that kind of problem where they write the percent on here? They're going to give you that. I'm going to ask you a question. You do not need to know all of these to answer that question. Sure, I know this one's 13.5, and then there's another one and another one, but you don't need to know that. What percent of the snakes were 400 or larger? What percent of the snakes were 400 grams or larger?
60%?
60 is not correct. What percent of the snakes were 400 or larger? Don't overthink this. It's a nice, easy answer. Say it if you know it. 50% of the snakes. Because it's right in the middle. And half the data is to the right, so we know 50% of the snakes would have to be 400 or larger. All right, then if you understood that, or even didn't, but now you get it, here's a follow-up question. What percent are 380 or larger? Don't say it out loud. Please write this answer on your paper. What percent of the snakes are 380 or larger? Hint, it includes the last answer we just did. And the last answer we just did was that 50% of the people of the snakes were in there. So you just had to add this and it was 84. Raise your hand if you knew it was 84. Okay, awesome. Any questions about that? Because this is 34 and this part was 50. Put them together, there's 84% of the snakes would be between there. Okay. Then there's another kind of thing on stats, and that's where I give you 2 lists, L1 and L2, and you put them in your calculator. For those of you that just logged in, you have to go put your diagnostics on. You'll have to do that on the real test too. Go right now to catalog, it's up right above the 0 key, and make sure diagnostics are turned on. Because that's how you get R value. So right now, on your calculator, on your iPad, turn diagnostics on with the catalog button. And then I'm going to give you 2 lists that you're going to type in. And then you're going to be able to tell me the R value, and then you're going to be able to tell me the equation for them. All right, so here, one step at a time. Everybody hit the stat button, and then edit. And then you're going to put in these numbers. 8 goes with 10. 11 goes with 13. 12 goes with 14. 15 goes with 18. And that's going to be good enough. If you put in just those 4 pairs of points, 8 total numbers, in list 1 and list 2, then you'll be ready to tell me the linear regression, and that's just that thing called linreg. That's under stat. Calculate linreg. Once you've done that, I want the y equals, and I'm writing an example. I'm not saying this is the answer, but give me an equation like that and tell me the r value. I'm going to pause for a minute so I can walk around and help people that are getting stuck. On the real test, we're going to have like what these are. So I'm going to say this is study time. And this is score. Is there a correlation between studied hours and score? And I know you know this. If you take a bunch of kids and they don't study at all, and you give them the test, and you take another group of kids and they study for 8 hours, of course they're going to do better on the test. You know that there's going to be a positive correlation. All right, so I'm pretty sure that the R value came out to 0.99. Raise your hand if you agree that it came out to 0.99. Okay, awesome. And that means that there's a strong positive correlation. Those 3 words you'd have to say. Strong positive correlation between study hours and score. Okay. The equation was definitely not 0.45x. Damien, tell me what it was. Use 2 decimal points, or 2 decimal places. For this, yeah, this was the part of the equation that we need. Y equals what? 1.1. You'll give me one more decimal place. 1.14. Okay. Would the next number make that round up or not? Okay. And then what's after the x plus? 0.64. Is that supposed to round up or not? Okay, good. All right, cool. Then raise your hand if you had the same equation as him. Okay, good. Now, here's the follow-up question. Suppose a person got a score of a 20. Figure out how many hours they studied. Suppose they got a score of 20. Now, there's only 2 places you could put that, and I want to prevent, some of you are putting it right here, and that's not where scores go. Look, the X was the study hours, the Y was the score. I told you the score, so I told you the Y. You can't just always stick things in X. I told you that the score was a 20, that means the 20 goes here. Who put their 20 there? Okay, good. Then what do? Well, I'm going to rewrite the equation. 20 equals 1.14x plus 0.64. And then I'm going to subtract the 0.64 from both sides. And I'm going to get 19.36, I think. Yep. Equals 1.14x. And then I'm going to divide both sides by 1.14. What is 19.36 divided by 1.14?
19.36 divided by 1.14 is approximately 16.9824.
And now, since I was rounding to 2 decimal places, let's just say 16.98. If they rounded to a whole, obviously it'd be about 17. So what does that mean? That means if you had a score of 20, you must have studied for about 17 hours. See how that kind of makes sense from the rest of the data? Yes?
So on the test to identify like y and x and which ones they are, what's like the easiest way to do that?
Yes, they're going to tell you what the number they're giving you is. Like I gave you 20 was the score. there's only two choices. That's either the X or the Y. So then you go look at your chart and you go, they gave me a score. And then if you look at this chart, you see where it says score? It'll be pretty obvious. Oh, they gave me a score. That's this one. And the column on the right, that's the Y value. And the first one, the L1, this is always the X value over here. Okay, so if they give you something that is on the left, that's your list 1, that's your X. If they give you the thing that's on the right of the chart, that's your L2, and that's your Y.
So they'll give you a chart, right?
Yes, they'll have to give you, if they just say, here's the weight, well, you have to know which one that is. Like, they'll have to tell you which one weight is. Okay, all right. Now, we're done with, oh, wait. Yeah, we did the R value already. So then we're done with stats and data, and then we're on to the last unit, which we're going to talk about is probability. Do you remember we had two tests, probability A and probability B? So I'm going to cover some of the highlights from that we know we might ask you for the final. I'm not going to waste your time. Put a C in 2 parentheses. If you remember this kind, this is the kind you would use if you're a 70% free throw shooter and you go out in your backyard and you shoot 3 shots. Remember that kind of question? This would be the great example of something you should put on the sheet, unless you already know this like the back of your hand. If you already know it like the back of your hand, then fine. Don't put it on your little half sheet. But that half sheet can have example problems. This will be a great example of a good example problem. All right, say I'm a 70% free throw shooter. You should know now 2 numbers, not just 0.70, you know another one. And this is about making free throws, and of course that means it's also about something else. And now if I go in my backyard and I shoot 3 shots, you should know where that goes. Then the question is always a probability question. So I'm going to read the question one more time from the top. I'm normally a 70% free throw shooter. I'm going to go in the backyard and shoot 3 shots. What's the probability I'm going to make 2 out of 3? 3 shots, make 2. You may recall I'd circle these to remind you that they all go together. If I'm making 2, then I'd put a little squared right there. By now you should know this is 0.30. These together have to make 100%. And this is supposed to be about misses. And if I made 2, I must have missed 1. You think you could type that in and get that answer on a calculator? Cool. Then that's a really complicated question most people off the street would not be able to answer. Because you've got to know this little formula, this little binomial thing to do it. Okay. That's one probability question. Here's another one that a ton of people get wrong, and I get it. These weird symbols are hard to remember. Apple, banana. If I say 0.3, 0.2, 0.2, and I don't know what goes out here, I couldn't believe how many kids last hour didn't know what that number would be. Take a second. Copy this chart. It'll only take you a few seconds to make 2 interlocking symbols. Copy the chart and tell me what goes in the little blank out there. This would be like level 1 about Venn diagrams. Just think about what these add up to. If this adds up to 3, 4, 5, 6, that adds up to 0.7. It should just be like, I hope it's obvious that that's 0.3. Raise your hand if you knew it was 0.3. Good. Then those people don't like bananas or apples, right? So then we ask you questions about it like this. What's the probability of apple? And that means you grab a random person out of the group. What's the probability they like apples? Now notice the question isn't about bananas. It's just, do you like apples? See, people get confused on whether it's 0.3 or 0.2 or both of them. How many of you knew it was 0.5? In other words, both of them. Okay, good. If you didn't know that, you have to ask yourself, if you ask the people in the middle, do you love bananas? They'd say yes. That's why you got to include them. All right. Now, how about this symbol, though? A ton of people last hour got this wrong. Apple, union, banana. That little U symbol. Don't say it. Obviously, there's two different ways you could get this answer. One of them's right, one of them's wrong. Would you please talk to the kid next to you about what you think that answer should be? See, there's two groups of people. Some people think the answer is 0.2, and some people think the answer is 0.7. So you got to pick a side. All right. Well, here's some things you should know, and maybe you should write down on your little sheet. This means or, and then it means you could ask the people the question, do you like apples or bananas? And what would they say? Yeah. It's like you got an apple in your hand and a banana in your hand, and you're walking up to them and saying, do you like apples or bananas? Don't overthink this. These would say yes also. They like apples or bananas. In fact, they like both. And these guys would also say yes, so it's 0.7. Raise your hand if you had 0.7. Awesome. If you didn't know that one, you better write that down. Probability A intersect B is 0.2. In case you want the difference, I'd write both of those examples down. Yes, you add on the union kind, you add them all up. On the intersect kind, you know what a street intersection is, right? It's where the two roads cross. It's only the part where they cross. So those answers are pretty small. Do you get on Highway 7? There's only a few square feet of intersection. Almost the whole road is not intersections. Intersections are a small part. So these answers are small. Intersections are a small part of the road. This is like the whole road, including the intersection. These answers are big. These answers are small. And if you want a snappy little word like or, the snappy little word for that kind is and. Do you like apples and bananas? Only these people would say yes. Point two. Okay. Hopefully it'll help you with some of your probability unit. There's one more thing that we got to talk about, and that's the P's and the C's. If I just give you a problem this easy on the final, I hope you'd be able to rock that. Take a second, use your calculator, and figure out what 5P2 is. Hint, it's NPR, and it's found under math. Hit the math button, find it, find 5P2. But a little harder than that would be if they said, we have 5 people in a race, and they're going to keep track of 2 medals, first place and second place. If they said all those words, you'd have to know, oh, you mean 5P2. How do you tell the difference between 5P2 and 5C2? It's about the order. And the porter matters. The P kind, the order matters. Porter. You remember it however you want. That's a way to remember it. The porter matters. See, in a race, of course order matters. You want first place, it's better than second place is. Okay? But on some things, order doesn't matter in the real world. If I just say, hey, 2 of you, would you help me carry this? It's kind of heavy. Then the order of the kids doesn't matter. I don't care what order I pick them in. Just these 2 kids. All right. So, order kind, P. One last thing about these. Oh, wait. First, Marcel, what'd you get for 5P2? What is the answer?
20.
Raise your hand if you guys had 20. Okay, awesome. Then don't get these confused with the simple choices. I have 3 shirts I could have picked from that would have gone with these pants. Because black works with this green color. And there's a couple other shirts I could have picked, okay? If I just say I have 3 shirts to pick from, and I do have 2 pairs of green pants. Okay, I got this kind and a different kind. Well, and I can have 6 combos, because you just multiply choices. 3 for the shirts times 2 for the pants. So if I just give you choices like that, you got 3 shirts, 2 kinds of pants, you just multiply them. Don't overthink it. All right. And that, ladies and gentlemen, is the last math lesson of the year. Tomorrow we'll just have a practice test. You'll be able to ask me questions that you want to ask me. And then Friday is the actual final. And you're playing defense right now. You just want to make sure you don't let your grade drop. Have a strong enough score that you won't drop. There's a rare kid where you're close enough that a straight A on the final could possibly lift you, but there's not many of that. There's a lot of kids where if you have an A going especially, those are the easiest to lose is an A. If you have an A going and all of a sudden you pull off a C on the final, it can be enough to lose the A. Okay, so play some defense, do some studying, and that's all I got for you for today.